So let's talk about scaling. And so scaling is going to be one of the activities we use applied proportions for. And I want to show you a problem that we can go after really two different ways. Suppose we have a house and it's 10 inches at the base. This is a model house and it has a height of 15 inches. And then it's modeling a house that's 50 feet, but we don't know the height of this house. Say that's capital H. What we're going to follow is this. The big base over the little base equals the big height per little height. And we could flip this. We could say little base over big base, but if we do that, we need to make this little height over big height. If you flip one, you've got to flip the other. The other thing we want to watch out for, make sure we're using the same units. So when we set up a proportion, this needs to be converted to feet if we keep this as feet, or this needs to be converted to inches if we keep these as inches. So really, there's an advantage to one or the other. It depends. Suppose we want to convert these into feet. Well, 15 inches times 1 foot for 12 inches. Those cancel, we leave feet behind. So 15 times 1 foot over 12, and this is 1.25 feet. So we'll convert this 1.25 feet. All right. Now we kind of convert the 10 inches, and this is going to be a little problematic. If we convert 10 inches to feet, inches cancel, feet are behind. So that tells us we've set the conversion up correctly. 10 times 1 foot divided by 12, and this becomes 0.83 repeating feet. In this repeating decimal, we want to be careful because if we don't actually have the full decimal number, we could be dealing with round off error. In fact, we're always going to be dealing with round off error. So we want to be careful with this. And this might be something I want to put off to the side. 10 times 1 foot over 12 is 0.83 repeating feet. So when I actually do my calculations, I might do this calculation again to summon this decimal and use it when I do my computations. So I can cut down on round off error. We'll consider a way where this isn't going to be a problem later. But all right, these are our measurements. So we've got everything in the same unit. Oh, pardon me. So now we set up. So big base, 50, little base, 0.83 repeating. Big height, we don't know. That's that capital H. Little height, 1.25. And now we cross multiply. Let's see, 50 times 1.25, 62.5. So now we're going to need to divide both sides, and this is where that calculation becomes tricky, by 0.83 repeating. Now, what I usually do is called 0.83 repeating is, in my calculator, I'll call it 0.8 and then type in as many threes as I can. And all right, fair enough. But I might want to summon that number again. And usually in a scientific calculator, when you make a computation, it's automatically saved as an answer. And so when you hit the answer button or the second answer button, wherever that answer is ANS, that will summon that computation that you just did. So I'm going to redo this. So what we're going to end up getting is the following. Let me set up the computation first. We're getting this now. 62.5, H equals 62.5 divided by 0.83 repeating. So in my calculator, I'm going to do 10 times 1 divided by 12. Okay, it's got that 0.83 repeating. And so what I'll do is now take 62.5, divide by answer, or previous answer is what it really means, but answer, and it comes out to 75. There we go. So how do we not deal with this? Well, there's a way we can do that. The way we can do that is the following. Let's try this. Let's go back to the original measurements. So this was 10 inches. And this was 15 inches. Instead, let's convert this into inches. So now the inches go on top and the foot goes on the bottom. So you have 50 times 12 divided by 1. And that gives 600. So now 600 inches. Now what we're going to want to do is really, when we think about the heights of things, we do tend to think of them in terms of feet instead of inches. So we'll want to convert the answer at the end back into feet. So again, large base over small base equals large height, which we just happen not to know, over small height. And this is great because we don't have any repeating decimals to deal with. So this is a good way to go. It just requires that extra step at the end, the conversion. So 10 times H equals 600 times 15. Or 10H, let's see, 600 times 15, 9,000. Divide both sides by 10. So H is 900, but it's 900 inches because we converted everything. We kept these as inches and converted that into inches. But really, this is going to be more understandable as feet. So you've got to convert 900 inches into feet. So now the feet go on top, inches go on the bottom. And we know we set this up correctly if the inches are canceling because one's above, one's below, leaving feet behind. So it's 900 times 1 divided by 12. And sure enough, if we do that, this is 75 feet. That's it. So if we convert everything into inches, then solve for the height, we don't have to deal with any of those repeating decimals that, well, we might cause more round off error. So we want to be careful. And just remember that if you do this, you're going to have to convert back into feet at the end. But the key thing here, when you have scaling, make sure everything's in the same units. And you're going to do, say, large base over small base, large height over small height, or you might abbreviate it like this. But you could, again, flip it. But if you flip one, make sure when you set up, you're also flipping the other. And that's it. So that's scaling. Any questions? Let me know.